We've previously described momentum as moving mass, which is dependent on mass and velocity. But kinetic energy is also dependent on mass and its velocity. Both require a force to change them. What then makes momentum important? It turns out that momentum also has this remarkable property of being conserved under certain circumstances. It is the conservation of momentum that enabled rockets and space exploration. It helps us understand collisions or interactions between objects, and it's given us cool toys like the flyboard. When there's an interaction between two objects, like a collision, if there is no net external force acting on the two objects, that is, the only forces acting on the objects are the forces that the objects exert on each other, then the total momentum of the two objects remain constant. So momentum is conserved, and the momentum before the collision is equal to the momentum after the collision, even though the momentum of the individual objects might have changed as a result of the collision. In the case of two masses colliding, the conservation of momentum is written as the total momentum of mass 1 and mass 2 before the collision being equal to the total momentum of mass 1 and mass 2 after the collision. In this formula, the prime or the subscript dash represents the case after the collision. Let's have a look at an example. Consider the following example where we have two billiard balls. The first ball is the number 1 ball with a mass m1 starting from the left of the screen and moving to the right with the initial velocity v1. Then there's the second ball, the number 2 ball with mass m2 starting from the right of the screen and moving to the left with the initial velocity v2. Before the collision, the number 1 ball had momentum given by the product of its mass and its initial velocity. The same is true for ball number 2. They then collide with each other, and being hard balls, they rebound from each other and move back in the opposite directions with the final velocities v1 prime for ball number 1 and v2 prime for ball number 2. After the collision, the number 1 ball has momentum given by the product of its mass and its final velocity. The same is true for ball number 2. The law of conservation of momentum tells us that the total momentum before the collision is equal to the total momentum after the collision. So P1 plus P2 must be equal to P1 prime plus P2 prime. Let's now put some numbers to our example. Consider that both balls have a mass of 160 grams and ball 1 was moving with an initial speed of 3 meters per second while ball 2 was moving with an initial speed of 1 meter per second. After the collision, the number 1 ball bounces back with a final speed of 2 meters per second. Let's define going to the right as positive, so that any vector pointing to the right will be positive and any vector pointing to the left will be negative. So the initial velocity of ball 2 and the final velocity of ball 1 will be negative. What is the final velocity of ball 2? The initial momentum of ball number 1 is m1 v1 and the initial momentum of ball number 2 is m2 v2, while the final momentum of ball number 1 is m1 v1 prime and the final momentum of ball number 2 is m2 v2 prime. At this point, we can rearrange this equation to get v2 prime being equal to m1 v1 plus m2 v2 minus m1 v1 prime, all divided by m2. If you're unsure how the equation was transposed, please ask your facilitator or one of the peer mentors for assistance, but it's important that you're able to do this. Now we can plug in the values for each of the known parameters. Solving for v2 prime gives us a value of 4 meters per second. Notice that the answer is a positive value, indicating that ball 2 will rebound back to the right or in the positive direction as we would expect. This is an example of what is called an elastic collision. An elastic collision is one where two objects bounce apart after the collision. In an elastic collision, both momentum and kinetic energy are conserved. Now let's replace the two billiard balls with a car and a truck. The car has a mass of 1,780 kilograms and is moving at 16 meters per second in the positive direction, while the truck has a mass of 3,600 kilograms and is moving in the opposite direction at 9 meters per second. This time when the vehicles collide, instead of rebounding, they stick together. Based on your intuition, what direction would the two vehicles move in after the collision? Now let's apply the conservation of momentum to find out. The conservation of momentum states that the total momentum before is equal to the total momentum after. But since the vehicles are stuck together after the collision, then the final velocity of the car is the same as the final velocity of the truck. Let's just call this common final velocity as v prime and take it out as a common factor on the right side of the equation. Now we'll rearrange the formula to solve for v prime, which gives us the momentum of the car and the momentum of the truck before the collision divided by the sum of their masses. Now we can plug in the values for the known parameters and solve for v prime. So what is the final velocity of the two vehicles? The final velocity of the two vehicles is minus 0.73 meters per second. So they both move towards a negative direction, but with reduced speeds. We can see in this example that the truck has much more momentum than the car because of its larger mass, even though it was initially moving at a slower velocity. The net momentum before the collision is to the left or the negative direction. So the net momentum after the collision must also be to the left or the negative direction because of the conservation of momentum. The car had no chance of pushing the truck backwards unless it was going at a faster speed. At what speed must the car travel such that the collision left the two vehicles stationary at the point of collision? That is, neither cars will rebound or move after the collision. This type of collision is called an inelastic collision. An inelastic collision is one where some energy is lost due to the collision. The energy lost is converted to some other form of energy, such as sound or heat, or in this case, deformation of the car and the truck. In an elastic collision, only momentum is conserved and kinetic energy is not. In summary, the conservation of momentum states that in the absence of any external forces, two objects colliding with each other will have the total momentum conserved. That is, the total momentum before the collision will be equal to the total momentum after the collision. Of course, this all applies for multiple objects and not just limited to two objects colliding.